So we're the tbbsbioneedle. I'm Trevor Hafer, and this is Suzette Mastrangelo.
Lung cancer today consists of more than 25% of all new cancer diagnoses in the United States annually. Unfortunately, this remains the leading cause of death in the United States. Some current ways to detect lung cancer are, as seen on the left, is a surgical technique. The surgical technique is highly invasive, but yet it collects quality tissue. It must be done in an operating room and has a long recovery time. The one on the right is a transbronchial biopsy technique. This technique is minimally invasive, yet it collects poor quality tissue, such as cell aspirates and blood. It does have a short recovery time, and it can be done in an endoscopic suite. However, these cell aspirates and blood that are collected are very difficult to test in a pathology lab, and thus it is very difficult to actually detect what type of cancer the patient may have. We have decided to optimize this type of device, and because it is the most commonly performed biopsy technique today, even though its results are not great. The way we have optimized this design is by creating our own set of controls, needles, and forceps, as seen here. We have focused mainly on the needle and forceps portion of our device. This needle and forceps portion has an outer sheath, seen here, that helps protect the needle and forceps assembly from poking out of the sheath and into the bronchoscope. Inside we have a coil that helps guide the needle through and also prevent puncture to the bronchoscope at the tip. Then we have a needle to cover the forceps and also allow us to penetrate into lymph tissue that we are wanting to sample. The forceps component is the most innermost component of the device, and it contains a cavity for which the tissue can be collected, as seen here.
So, as Suzette mentioned, our method can collect a whole core biopsy sample. So, the competitors we have are Boston Scientific, Cook Medical, and Olympus. They all do transbronchial biopsy needles, but they all do it through cell aspiration, unlike our device. Currently on the market, 75% of thoracic lymph nodes are performed through biopsies, and 95% of these are being performed through a bronchoscope. So that results in a $1.5 billion market, with $200 million being in needles alone. And we estimate 2 to 4% of that capture, which is $4 to $8 million. The cost of the prototype is $106 to manufacture. With production, it would be $125 because it uses a wire ADM to split the forceps to collect the tissue. The sales price would be $150, which is $50 to $75 less than any of our competitors. Our exit strategy, we want to continue design improvements. We want to file a utility patent because we already have a provisional. And we want to be able to validate the design and then manufacture the design and then become acquired. And so the values behind our device are that our device can collect whole core tissue samples while maintaining minimally invasive surgeries. Thank you.